This is a video on function basics, domain and range. So we need to cover first a few things before we get into domain and range. What is a relation? A relation is any set of points. So there doesn't really have to be any restrictions on a relation. But a function does have restrictions. For a relation to be a function, a relation is a function when each value in the domain is paired with a unique value in the range. So that's kind of weird wording. Let me reword that in something that you might understand a little bit better. X cannot repeat. If X repeats, the relation is not a function. If X repeats, the relation is not a function. So I talked about in the definition of a function domain and range. So let's discuss what domain and range is. Domain is usually associated with X, or what we call the independent variable. Sometimes it's not X. And then range is associated with Y, or the dependent variable, in case it's not Y. And I usually remember that because domain comes first in the alphabet before range, and X comes before Y. So domain is X, it's your first variable, and range is Y. So if you're looking at a point, for example, X comma Y, X is domain, Y is range. Why is domain important? Domain is important because it tells us where restricted values might be. It also tells us if a relation is a function, which relates to that. So some different types of functions that you'll see. Obviously, one is linear. I wrote it down there already. Linear is a straight line. There's also quadratic. And feel free to pause and go back if I'm writing too quickly, which is a U-shaped graph, or upside down U. There is rational, which can look a lot of different ways, but it kind of bins like that. Radical and exponential. Those are just some different types. There's logarithmic, there's other types, but these are just a few. Okay, let's look at these examples. We're determining if the following is a relation or a function or both. So in this first example, we have what is called a set of points. And any set of points is a relation. Now we have to look at the domain to determine if it is a function or not. So let's look at the domain. We have a 1, a 1, a 2, and a 3. I'm going to write those down. 1, 1, 2, 3. Does x repeat? Yes. So since x repeats, it is not a function. It's disqualified. So since x repeats, it is not a function. This next one beside it is called a mapping, and it is showing you how the points are mapped. So this point is 1, 2. This point is 3, 5, 6, 9, 10, 12. So it's telling you up here, this is the domain, this is the range. We know that domain is typically associated with x, range is y, so that's why I wrote the points in that order, and it does matter. So is this set of points a relation? Yes. Any set of points is a relation. Is it a function? To know if it's a function, you look at your x values. If x repeats, it is not a function. So does x repeat? X does not repeat, so we are good. Yes, x does not repeat. It is not disqualified. Kind of weird wording. If x does not repeat, then yes, it is a function. And then this last one here, this is called a table of values. This is also a set of points. So we would write this point as 0, 4, 0, 4, 1, 4, 2, 4. It does not matter if the y's are repeating. What we're focusing on for a function is the x values. So is this a relation? Yes. Always. Is it a function? No, it is not. 0 repeats, so no. It is not a function. What are two quick ways you can tell if a relation is a function or not in a set of points from a graph? So we didn't actually have an example with a graph. I'm going to show you a quick example based on the table of values. So the last one we did, I'm going to draw a quick sketch of a graph here. Let me draw some 1, 2, 3, 4, 1, 2, 3, 4. I only have positive points, so I can just do that quadrant. We had 0, 4, 0, 4. Again, I'm just going to draw it kind of small in there because it's overlapping. 1, 4, and 2, 4. So we use what is called a vertical line test. And that means that you take a vertical line and run it through the graph. So you can use your pencil or your hand or something straight up and down, run a vertical line through the graph. And you'll notice right here that my vertical line hits 2 points at the same time. So this fails the vertical line test. Therefore, it is not a function. Let's do something a little more simple, easier to see. Let me just draw a sketch here. Let's say I have a graph that looks like this, kind of a sideways U. I'm going to take a vertical line. Anywhere you run it through the graph, you'll notice that if I just sketch a vertical line here, my vertical line hits 2 places at one time. So this fails the VLT, therefore it is not a function. If it hits 2 places using one vertical line, it is not a function, because that means that x repeats. This point would be like -1, 2, and -1, -3. So I'll just write those out to give you a visual. This point would be -1, 2. This point would be -1, 3. Therefore, x repeats, and it's not a function. So that is called the vertical line test. And you can use it on graphs to see if something is a function or not. These are a couple functions that you're going to see throughout the semester and on into college algebra. So these are the types of functions that I mentioned earlier in the lesson. Y equals x is called a linear function. If you were to graph it in a graphing calculator, then it would look like this. And it is a line. It technically goes on forever in both directions here. And then if you were to look at a table of values, that's what it would look like. You can see it goes up linearly. It goes up 1, 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 up 1. It's linear. It doesn't jump a lot between values. It grows gradually, linearly. This next one, y equals x squared, is called a quadratic function. And its graph, I'm just going to sketch one for you, is a U-shaped graph. And I'm just going to show you really quick I have a calculator app. Let me find it. This is a free app, EDU Calc Classic. I'm going to go to y equals down at the bottom left. I'm going to clear that. I'm going to type in x raised to the second. That means x squared. Save it. Then I'm going to go to the graph, and you can see it's similar to my graph that I sketched. And then I'm also going to go to the table, which is in the center at the bottom, and this gives you an idea of what the points look like. So 1 squared is 1. 2 squared is 4. 3 squared is 9, and so on. So that's how the table correlates to the graph. So I'm just going to do a little short table here, x's and y's. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. This next one is called a radical or square root in this case. Square root of x. So if I go to my calculator app and I type in square root of x, save it, graph, you can see, I'm going to zoom out so you can see it better. It starts at the origin and then kind of goes up and to the right. And then if you look at the table, we have lots of decimals here. Now look here. In the negative numbers, it says complex numbers available in paid version. So I have the free version, but basically what it's telling me is that it cannot do these numbers, and I'm going to show you why back here. I'm going to sketch a graph really quick just to show you. It goes that way. And then if I were to look at a table, x and y, if I tried, let's try -4 for example. The square root of -4, you can't take the square root of a negative number. So this is going to give you an error. It's an imaginary number. But if I did 0, that's okay. If I did 1, that's okay. If I did 4, that's okay. So positive numbers are okay. It's the negative numbers that gave us issues. We're determining if the relation is a function, and then we're talking about the domain and range. So we can use our vertical line test to determine if something is a function. Your linear functions will always be a function, and the domain will always be all real numbers, and the range will also be all real numbers. Now that's a symbol for all real numbers, and the reason why I know it's all real numbers is because in this graph, this goes on forever. It stops on my paper, but it actually keeps going forever and ever and ever. So all the x values are good in both directions, and all the y values are good in both directions. See, this is a point. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. These are all points that correspond to places on the graph, and it goes on forever, and we call that all real numbers. You could also write that using interval notation in negative infinity to positive infinity. If we did a vertical line test on a quadratic function, yes, it is also a function. It doesn't overlap anywhere. And then if we were to look at the x values on the graph, all of these x values correspond to something on the graph. So the domain is all real numbers, or negative infinity to positive infinity. But the range, that's your possible y values. Your y values start here and go up. There's nothing down here. There's no graph down there. So your range starts at 0 and goes up. So we could write that 0 to infinity. You'll notice that I put a bracket on the 0 because 0 is included. And I put a parentheses on infinity because you can't include infinity. And then the square root function, if we did a vertical line test, it does not overlap anywhere, so yes, it is a function. Domain, the only place I see x's is on this side of the graph. So from here over, are possible x values. 0 to positive infinity. And the range, I have the same situation. It's here, and then if this were to keep being drawn, it would go up and up and up. So it's also 0 to infinity. Now I want to show you something here. You'll notice let me go back to the calculator. Oh, that's the same table. You can kind of see the domain and range from the table because your x values on the left side, your values start at 0, and you have corresponding y values for 0 all the way to infinity. It goes on forever. The problem starts coming in when we have negative numbers. So we can't have any x values that are negative or any y values that are negative. It doesn't work. We can only have values for x and y starting at 0 and going up forever. So that's also another way to look at domain and range, is by looking at the table. And you could see that in quadratics. Let me just show you that really quick. You type in x squared, go to the table. You can see the table, there's no errors, there's no problems here. My table does stop, but that's just because it's a free calculator. You will notice that 0, 0 is the lowest point, and then on either side of that it goes 1, 1, 4, 4, 9, 9, 16, 16. So that's showing that U-shaped graph. We're at 0, 0, and then it goes up from there. So it only has positive values in its table, which shows there. Positive y values, sorry. And then this is called a rational function because it has an x in the denominator. It looks something like this, depending on the function. It has this little graph here, and this little bit here. And you'll notice that it's broken up by the x and y axis. And you can see that in the table here. There's an error at 0. Sorry, x equals 0. That's right here. That's my bad. And that is called an asymptote. And that is a place where the graph cannot equal. And that's because there is a variable in the denominator. And if you remember from algebra, maybe from high school, if you have 0 in the denominator, if 0 is under the fraction, it is undefined. And so when x is 0, it makes an undefined number and causes an error. So that means, yes, this is a function. For the domain, x cannot equal 0. Can be anything else, just not 0. And then for the range, we can go from negative infinity to 0, and then that's a union. I'll explain this in a second. Okay, so what I wrote looks kind of weird. I did negative infinity to 0, and I put a parentheses because I cannot include 0. This is called a union, which means that we have some graph on the left side, it skips over 0, and it continues on the right side. So that's why I start there again with a parentheses. This is called an exponential function because the x is an exponent. The variable is an exponent. Up here, the variable is in the denominator. So this is kind of how you can identify. This E is actually just a number. It's kind of like pi. It's not equal to pi, but it's kind of like pi. It's just symbol for a number. And putting this exponent up here makes it an exponential function. The graph of an exponential function looks something like this, depending, because it might change. This is just the parent function. And then here is the table for an exponential function. So you can see there's not really any errors, which means that, yes, this is a function. Domain, since there's no restrictions, negative numbers are okay, zero's okay, positive numbers are okay, then all real numbers are good. Don't assume just because the domain is all real numbers that the range is also. Look at your graph and see where your actual y values are. The y values start here and they go up. So all of our graph is in the positive y-axis. The x values are anywhere. Any x value is fair game, but the y values are only in the positive part of the graph, which means that the range is only 0 to infinity because it's only in the positive part of the graph. So if it had been, just to kind of back up and show you, if a function had been like this, for example, that's a terrible graph, but you get my point. The domain is fair game. Any of these x values correspond. So the domain is all real numbers. But the range, the only graph is down here in the negative y-axis. So that goes from negative infinity to 0. That's the negative y-axis. It's only down there. So you just have to be careful. Look at your graph, look at your table, and decide. If you're having trouble reading a graph, it's always a good idea to look at the table of values. And we did that. We looked at these. That's just kind of a quick thing. Oh, I forgot there's one down here about domain and range. It's a pretty big overview of a lot of information, so you might want to go back and look back over these and kind of look at them with a little more depth. But this was just kind of a summary of those functions that you'll be seeing in algebra. This function is something you might not see in algebra, but I just wanted to show you it because I think it's fun. This is the equation for a circle because it has that x squared and y squared. That's the equation of a circle. And I wanted to do this because, well, I like circles, but I wanted to show you an example of domain and range for a circle. So let's say this is my circle. Oh, you know what? I have a circle tool. Here's my circle. So is it a function if I drew a line through it, a vertical line, does it hit in more than two places at one time? One place at one time, sorry. So no, this is not a function. The domain goes from, this would be at, whoops, 1, that's negative 1, 1, 1, negative 1. So the domain goes from negative 1 to 1, and the range goes from negative 1 to 1. Again, you're not going to see a lot of circles as far as like writing equations and understanding how I got 1. I got the 1 from here if you're interested, but I'm not going to test you specifically on that, so I don't want you to have to worry about it. I just wanted to show you an example of a circle that it is not a function because it hits 2 places at one time on a vertical line test. And then I wanted to show you the domain and the range because I thought it was cool. We learned in a linear function, remember the linear function was y equals x, that there were no restrictions on the domain because there wasn't anything that's not allowed. X can be anything. This here, x can be negative number, and x can be 0, x can be positive, x can be a fraction, a decimal. It can be anything, so there's no restrictions. On a quadratic, there were also no restrictions. Same thing, you can square anything. You can square negative numbers, you can square positive numbers, you can square 0, you can square decimals, fractions, you can square anything. So there's no restrictions. It was the square root function where we had an issue. There were restrictions on a square root function because x could not be negative. Negative numbers under the square root create imaginary numbers, which you'll learn about in college algebra. So there were restrictions on a square root function because of the square root. And then a rational function, there were restrictions. The denominator cannot equal 0. It makes it undefined. The fraction undefined. And then an exponential function there were no restrictions. X can be anything. X can be 0, x can be 1, x can be a negative number, x can be a fraction. So that was okay. The only time it was an issue was with the square root and with the rational. That was a lot of information for this section. Most of this stuff I'm just trying to give you an overview of. In the homework, you'll be expected to basically read graphs and be able to determine domain and range, or you'll be given something like this page and determine domain and range, or if it's a function. So don't be overwhelmed or intimidated by this newer stuff that we've learned. I just wanted to kind of give you a brief overview of it so that when you do see it again, it's familiar and not scary. If you have any questions, please feel free to email me. I would love to answer them. Thank you for listening.